Thank you, thank you. Thank you. Thank you. All right, let's get started going over some of these. I know some of us are like, oh, we didn't quite finish. That's okay. We need to address some concerns, and there's specific problems that I picked to help us understand these concepts a little bit better. So first off, I need you all to remember, and I hope that this is starting to become apparent to you. In order to write the equation, what's the first thing you need to know about the sequence? What kind of sequence it is, which is based on the...
Common...
Say it. Common what?
Ratio.
Difference or common ratio. Isn't the sequence literally defined by the rate of change?
Yes.
Okay, so if you're going to identify what the equation is, you got to know what the rate of change is. So when I look up here, first off, it doesn't seem to be going by very much. So personally, I'm going to go, man, I don't think it's a common ratio. It's probably a common difference. So I'm just going to subtract. 1 3/5, which a lot of students struggle with fractions. I get it. But please hear me very clearly. All that 1 3/5 really means is 1 plus 3/5. And that fraction bar is division. You can plug that into the calculator and then subtract the previous. And you get 3/5. 2 plus 1/5. That's what 2 1/5 is. Then you subtract the previous. And I know some of us don't need that, but I want to address that idea. You can literally plug that in, and every time you do a difference, guess what you're going to get? 3/5. So, what are we doing to find the next term there? So notice how it's positive. We found a difference, but it's positive, so we are adding. Gentlemen, are y'all paying attention so you can learn this? Then turn in your desk and face the board and take some notes. So what would be the recursive rule that's driving everything here? First off, how does every recursive start? F of n. But Jamari, is that enough to define this recursive function? What do I still need? You gotta have a starting point. So Jamari, where would you say we're starting the sequence at? I mean, just look at the table. Where does the table start? 0, comma 1. So I could say f of 0 is equal to? That's it. Done. So to find the nth term, the first thing I'm going to identify is where the function is starting. Okay? So starting with what value?
1.
Starting with 1. Then what? Add 3/5. N minus 1 times?
Yes.
Is that correct? Oh, we're so close. Who can identify the mistake first?
N minus 1.
What's wrong with the n minus 1?
Because you're starting there. So you don't need to put away n minus 1.
What's my starting input? 0. So do I need to do n minus 1? No, for the first term I do need to add 3/5. So it's not n minus 1 times, it's n times. It's starting the 0th term, so it would be n minus 0 or just n. We do need to remember that we subtract 1 based on what the starting input is. Well, it's 0 this time, so we're not going to do anything else. Notice when I write this explicit rule, which you could use x and y if you want to. I'm going to stick with f of n and n. So what's the starting value that I'm going to put for this equation? F of n equals 1. Then what am I doing to the 1?
Adding 6.
I was adding 3/5.
I mean, not 3/5. I'm at 0.6.
Oh, 0.6. I got you. So 3/5 or 0.6, but mathematically, and this is a fundamental idea we got to remember, how do we show repeated addition? So I'm going to multiply by what? Notice, if I want the first term, don't I need to add 3/5 to it? To that one? So that's why I need it just be 3/5 times n instead of n minus 1. To get to the first term, I do need to add that 3/5. If I put n minus 1 there, I would not be adding the 3/5 because 1 minus 1 is 0. So we got to recognize those details. So arithmetic, geometric, or neither? Arithmetic. And I hate the fact that that question is last here. That realistically should be the very first question you ask. All right. Who got freaked out by F?
Me.
Right? We look at F and it's like, come again? But it's okay. Identify what's happening to you from 3 to 4 to 7 to 12. Adding 1, then adding,
Adding all numbers.
well, adding 3 there, adding, and it's going to keep adding by that, right? So is that arithmetic with a common difference?
No.
No. Is it gonna have a common ratio?
No.
So it's neither. This is actually what we call a quadratic function that we will study later this year. And you may not remember calling it quadratics, but hopefully you do remember parabolas. That shape. Look familiar, hopefully? That's what this is. Because I will point this out.
Yeah.
Notice there's a common difference there. Notice with a linear function, it's into the first power, right? When we had a common difference at the very beginning, right away, it was into the first. See how we have it at the second layer this time? So it's into the second. That's a quadratic. We won't study that till later, but it is cool to see how these things play out into our future. I'm going to skip G for now, but I will say G freaks some of us out. But very clearly, it doesn't have a common difference. No. So it probably is a common. If you can identify that right away, you can just do a ratio to see if it is common. Let's end on H though. A lot of us didn't like the fact that there was a negative in there, right? Is it a common difference? That's going from a negative to a positive and then a positive back to a negative. What's the only thing you can do to alternate back and forth between negatives and positives?
Add and subtract. Multiply and divide.
Multiply by a negative, right? The only way you can alternate back and forth between negatives is to multiply or divide by a negative. So it has to be a common ratio. 0.2 to its previous negative 1. Hey, that's a negative 0.2. Negative 0.04 to its previous 0.2. Guess what that's going to be?
Negative 0.82.
If I divide them, do the ratio, shouldn't it be the same ratio? So guess what I'm repeatedly multiplying by? Okay. These are the things we want to attend to before our assessment tomorrow. So to find the next term, what do we need to do?
Negative 22.
So don't just say times. Multiply by negative 2. So recursively, go. Negative 0.2. Recursively, f of n is equal to f of n minus 1.
Negative 0.2.
But I still need a starting point. So to find the nth term, starting with negative 1, multiply by negative 0.2, how many times?
N minus 1 times.
See, we need to recognize that. I'm starting at the first term, so it's going to be n minus 1 times. The n allows it to change, but the n minus 1 indicates I don't need to multiply 1 time. So the explicit rule. I'm starting with -1. Then what? Multiplying? How am I going to show that repeated multiplication? With an exponent of, if you can write out these statements, you can write these equations. And so then it's geometric. Here is your homework. The 1.8, set numbers 5 through 8. Re-examine each of your vocab terms. Determine if you can strengthen your ideas. The reason for that is you have an assessment tomorrow. So you need to think about your vocab and get through 1.8, set numbers 5 through 8. Those are going to be the practice you need to be better prepared for that assessment. Please take a picture of this and make sure you do your homework.
Okay.
What?
Your mommy.
I thought she was like calling you out. I was like, I'm so confused right now.
Yeah, I know. See, I did my homework last night.
See you tomorrow.
Hey, you can put this one.